In this video, we're going to look in more detail at static electricity and where it actually comes from. So from our review of matter and the source of electrical charge, we know that because all matter is made of a mixture of protons, neutrons, and electrons, all objects, therefore, are going to contain a mixture of positive and negative charge because all substances are made of at least protons and electrons. Now, we know when we studied the difference between atoms and ions that if the amount of positive and negative charge in an atom is equal, then that atom is a neutral atom and not an ion. And this also applies to everyday household objects, such as the balloon that this girl is holding in the picture. So if the amount of positive and negative charge in this balloon are equal, we say that it is electrically uncharged because neither the positive side nor the negative side dominates over the other. However, using a simple household experiment, we can actually get this to change. So if you were to inflate a balloon and rub it up against a thick sweater, wool in particular works very well, you can actually cause the electrons in one object to transfer to the other. So in this case, the material that this wool sweater is made of actually has a weaker attraction to electrons than the rubber that the balloon is made of. So rubbing one up against the other causes the electrons from the sweater to transfer into the balloon. This is what we called static electric buildup. So the word static literally means stationary, and objects that are stationary are not able to move. So we say that this is static electricity because, at least for now, the electrical charge, meaning the high concentration of electrons that have accumulated in this balloon, remain in one location, as in they are trapped in the balloon until we find some way of moving those electrons away. Now, this static electric charge that we've built up here has some pretty interesting effects on other substances. So we see that this negative charge is causing an attraction in the girl's hair. So how exactly is this happening? Well, we know that all substances contain positive and negative charge, meaning that there are electrons within the girl's hair. Now, we know because of the laws of attraction and repulsion, opposites attract and like charges repel. That means that the negative charge, the electrons in the girl's hair, are going to be pushed away from the static electric charge in the balloon like this, leaving the positive charge, at least by itself temporarily, and this can cause an attraction with the balloon, which is why it appears as though the hair is moving by itself and sticking to the balloon. But this is a very simple example of electrostatic attraction and repulsion. So what's going on here is that the negative charge can actually, what we call, induce the movement of electrons away from it and therefore cause the positive charge within the hair to attract to the balloon. So induce is another word that kind of means to force away. So the negative charge in the balloon is forcing the electrons away from the balloon, allowing the positive charge to form this attraction. So what exactly causes this behavior? Well, the answer depends on what the substance is and how likely that substance is to attract or lose electrons. So this data table here is what we call the electrostatic series, which is simply a data table that records a number of different substances and how likely those substances are to gain or attract electrons or lose electrons here. So the farther down the substance is, the more likely that that substance will be negative, and we know that negative charge happens whenever a substance gains electrons, causing them to become negatively charged. So if we look down here, you'll find polyester is a type of plastic similar in structure to the rubber that a balloon is made of, whereas we can see human hair, nylon, wool, fur, rabbit fur are all very high on the list, meaning that these substances are more likely to lose electrons and become positively charged. And this explains the behavior about why the electrons transferred from the wool sweater to the balloon, and how the electrons were able to push electrons in the hair away, causing this induced positive charge here. Now, remember how we said that static electricity is temporarily trapped in one location? Well, again, the word is temporarily. There are actually ways to release that charge through what we call a discharge reaction. So in order to cause the electrical charge to become discharged, we need to create a pathway that the electrons in one object can be transferred to another object, and eventually these electrons are going to be moving towards the ground. This is another simple experiment that you can do. If you walk around your house, particularly in wool socks, and especially if you have carpet, if you rub your feet up against the floor, you can actually cause the electrons within your body to build up here, and when you touch the doorknob here, which is made of metal, which is a substance that is very easily able to transfer electricity, you can get the electrons that you built up from static electricity to go through the doorknob, through the door, and eventually into the ground. And for anybody that's felt a static shock before, it can be quite unpleasant if you don't know what to expect. Now, for a far more extreme example, we can look no further than the lightning that occurs during a lightning storm. So lightning is just an accumulation of static electricity that builds up in the clouds, and when that electricity reaches a certain point, it will move from the clouds to the tallest object close by, which will then transfer that electrical charge deep into the ground. In the next video, we are going to focus in more detail on how to build up static electricity and how to create a static electric charge, and how to predict when static electric discharge occurs and the different situations in which we might see it.